Okay, lesson 6, identifying pairs of angles. There's specific names for angles that we need to kind of get used to. Okay, so let's first start with what? Let's first start with complementary. Complementary angles. Whoop. I already heard somebody say it. Go ahead and say it a little bit louder this time, Bailey.
Complementary is when they add up.
They add up to 90 degrees. Levi, supplementary angles
Add up to 180 degrees.
add up to 180 degrees. Thank you. Supplementary angles add up to 180 degrees. Okay, remember that in your labels, the degree symbol is just a dot. No big deal, but you have to put it in order to get the points for the dot. Okay? So, complementary angles will look like this. A 90-degree angle that is broken into two pieces or some sort. Okay? So, for example, a 30-degree angle and a 60-degree angle would be complementary. A supplementary angle will make a straight line, and it'll break it up to two more angles. So again, I'll use 30, and this one will be 150.
What is that top one?
30 and 60 is the top one. 30 and 150 is the bottom one. Okay, so just a couple examples. You don't have to get too crazy about them. Second, we're going to just start in on examples so we can start getting used to how the vocabulary works and what to look for. Example 1 says, example 1a, find the angles complementary to KLM if KLN is 90 degrees. So, I'm just going to try to put this on the screen if I can get rid of that big nasty glare. Okay. So, going back to what it asked for, it asked specifically about angle KLM. KLM. If the measure of KLN is 90. KLN is 90. So, what you should notice is that this box right here says that this angle is 90 degrees, and that the directions also told us that this angle is 90 degrees. So, if they share this middle piece right here, which is KLM, okay? If they share this middle piece, then I know that this angle and this angle must be equal to each other. Let me give you a picture to go with it. So draw exactly what you saw in your book. You can even copy it out of there. I don't really care. So put it over here or whatever and write it out. So we're going to use those same letters just for continuity's sake. J, K, M, N, and L. Okay, so it told you that this angle right here was also 90 degrees, which means it's a right angle. So, knowing the information that they gave us, I'm just going to plug in a number so that you can see it. If this angle in the middle, let's call it 60 because I've already used it once. If this one is 60, what do I know about this smaller angle right here? It's got to be 30, right? So, if these are 90 degrees, I'm going to ignore that right there. It told me that this whole angle was 90 degrees. So what does that leave MLN to be? 30 again. So now we can all easily agree that 30 is equal to 30, right? So to write this out, I would write JLK. JLK is going to end up being congruent to MLN. Now, I want to also remind you that you need this angle symbol in front of each of these angles so that we know what you're talking about. So angle JLK is congruent, that's the symbol for congruent, to MLN. So they're going to write some kind of postulate or theorem about this, and it'll sound very similar to what I'm about to tell you. If an angle is complementary, and then another set of angles are also complementary to the same angle, then they are congruent to each other. So that's basically what we just showed. If two angles are complementary to the same angle, then they are congruent to each other. And that's basically what they're going to end up saying about Theorem 6.1. Okay? Here's the exact wording from the book. If two angles are complementary to the same angle, or two congruent angles, then they are congruent. And then it'll say the same thing for supplementary. If two angles are supplementary to the same angle, then they are congruent to each other. Alright, looking at part B of example 1, which is on the next page if you have not already looked there. It says find the angles supplementary to DGF. Okay, again, here's DGF. So, DGF is indicated by the arc mark right here. Notice, I'm just going to draw a straight line using this paper. I'm just going to ignore the bottom part for now. Clearly, EGD is supplementary to DGF, right? You can see it pretty easily. It's on a straight line. If I did, I keep moving it. If I did this, I could again say that CGE is congruent to DGF because they are supplementary to this big angle right here. Because if I draw a straight line, see they're supplementary. I can do the same thing this way and this way. Okay. We should also know that these two angles are what? Starts with a V, ends in an vertical. Angles, thank you. The vertical angles. Vertical angles are congruent. So we're having problems with that definition. We're going to write it down. Vertical angles are congruent. Because definitions aren't the only things we need in geometry. We're going to also draw a picture. We'll draw one similar to what you just saw, but mark them congruent with arc marks. Okay? These two angles are directly across from each other, and they are equal to one another. I'm going to label them 1 and 2. And then I'm going to say angle 1 is congruent to angle 2. Vertical angles, sorry, that's plural. So what's going for? Most people pay Microsoft Word big money to make arches out of their words. I can do it for free. Alright, anybody still need this? For a second. We're going to be going to example 2 if you want to start looking at it. Okay, moving on to example 2. Example 2 starts with this crazy picture. It says find the measures of x and y. Okay, notice the box first of all. Okay, the box, it's in your book. The box is 90 degrees. Very clearly 90 degrees, Levi.
I know, I saw it.
Oh, I know you did, but you're talking, so please abstain from that activity. So, easy to tell what angle x will be. How do I find the measure of angle x?
Measure it with your protractor.
I'm going to subtract it because I know 90 degrees, and I just subtract what?
Either way.
Okay, so I'm going to subtract 55. If I measure it with a protractor, I'm probably going to get a degree or two off because of human error or the thickness of the line. So if I get this, I'm going to get the exact answer, which is what? Say it louder, Bailey. 35 degrees, and we'll circle my answer. Now that I know 35 degrees, what do I know about angle ABC?
180.
It's 180 degrees. So these four angles right here are supplementary to make 180 degrees. Typically when we talk supplementary or complementary, it's just two angles together, okay? So this makes a straight angle. Straight angle is 180 degrees, so I now know that I have the angle y plus the angle DBF, which is 55, plus the angle x, which was 35, we just found that, plus the angle 40. So I can add all those together, and I know that it's got to equal 180 degrees, right? So adding these numbers together, I know that these are 90. It told me that by drawing the box. So if you wanted to skip that step, instead of saying 55 and 35, you could have just said 90. That would have been fine. 90 and 30 make 90 and 40 make 130 degrees. So now we have y plus 130 equals 180. Do we have a question over there? How do I solve for y? I just subtract what? 130 from 180. Thank you. Okay, those go away. Y then must be 50 degrees. I can quickly check myself just by looking at the picture and adding them all together. Should equal 180 degrees. Any questions about it? I'm sorry. All right, moving on. The next example is example 3. I need to go over what a linear pair is, because a linear pair is basically the same as two other definitions that we would go with. So write down linear pair. A linear pair of angles, because the word pair means two, right? A linear pair are two angles that are supplementary. So here we go. Linear pair. They are supplementary. They are a straight angle. This is why I'm saying that this is repetitive. Okay, they are supplementary. They are straight angle. They are opposite rays. There are 1,000 different ways to say the same exact thing. But the most common things that you'll see all paired together will be linear pair, supplementary, and then straight angle. Okay, straight angle makes 180 degrees, so I'm going to write that lastly in there, because that's the most important part about all three of these things, is that they're equal 180 degrees. Okay, if I know that they equal 180 degrees, then I don't really need to worry about their definitions as much. But linear pair, most specifically, the difference between the two is this is only two angles put together. Okay, so looking back, if it says identify a linear pair, then I only get to name two angles. So, for example, I would say AFB or BFE make a linear pair. I could also say AFC and CFE. I could say EFD and DFA. Okay, there's a bunch of different ones you can use, but you have to use them together. Okay, be careful on how you write your answer. You need to write it. I'm just going to give you the example. It says identify two sets of adjacent angles and one linear pair. So we need to go over the definition of adjacent angles as well. But for a linear pair, to answer example 3, what is the linear pair? A linear pair would be angle AFB and angle BFE. You will notice something about these. They have two of the exact same letters. Because why? Well, because they're adjacent angles. Say that again? Yes, the F did say the vertex. They do share a common vertex as well. That's part of our next definition. Vertex. Yeah, I'll go back to it here in a second. I just want to show you AFB and BFE share this side, or this line, this ray, I guess, not really a line. Okay? Since they share that, they will also share that in the name. So FB, BF right there. Now, we're going to go over adjacent angles. adjacent angles are exactly what Chris just described. Okay? If they're adjacent, that means that they share a side. That's what adjacent means. So, when I'm talking about linear pair, the exact definition of a linear pair would be two adjacent angles that form a straight line. Two adjacent angles that form a straight line. So adjacent angles share a side. Okay, so they just simply share a side. That's as simple as I can put it. They share a side. The definition in the book will tell you that they share a side, but no common interior points. No common interior points. Okay, they go over the definition of vertical angles in the book. We're going to go straight into some examples using those definitions. So solving these, again, this craziness right here, they renamed 1, 2, 3, and 4. Thank goodness, right? So, a pair of vertical angles, two angles that I know are going to be congruent, are 1 and 2 because they're right on top of each other. So, I know that 1 and 2 are going to be congruent, which in other words means equal, right? If I say two things are going to be equal, then all I need to do is go in here and write them down as equal. So 2x minus 5 was angle 1 will be equal to x plus 30, which was angle 2. So I just set 2x minus 5 equal to x plus 30 because they're vertical. They're on top of each other and they are congruent. So I set them equal to each other and then I'll solve. And I'll do the same thing for the y. Okay. So again, I'm going to look at them. Without even having to do anything, you ought to be able to set these up before you even come and ask for help if you struggle with these. I should see 3 and 4 and go vertical angles. Those are equal to each other. Y plus 17 is equal to 2y minus 81. Okay. I'm going to solve each one of these individually. I'm not going to try to do them at the same time. So I'm going to zoom in a little bit. Okay, so 2x minus 5 equals x plus 30. I need to get all my letters to one side, all my numbers to the other. Okay, so I'm going to move the smallest x. I'm going to move the x. So subtract x to both sides. Somebody said move the 5. I'm going to move the 5 because I moved all of my letters this way. I need to move all my numbers that way. So I'm going to add 5 to both sides as well. Okay, so I'm working straight down here. I have a negative x and a positive x. Those cancel. I have a negative 5 and a positive 5. Those cancel. That was the whole point. So 2 minus 1 is just 1x. I don't need to write the 1 in front of it. I'm just going to leave it as x. 35 will be the answer to this particular x problem. Now, I have a constant problem. Somebody says, do I need to put degrees on there?
No.
No, because it's a variable. The degrees is right here. The variable is just how you will find the degrees once you plug it back in. So if x is 35, then I'd go 35 times 2, which is 70. 70 minus 5 is 65. If I want to plug it, I would just plug it back in here. 35 plus 30, 65. These two equal each other, so I know I did it right. Cool? I'm going to do the y part now. That was just me checking. I'm going to do the y part now. I need to move all my y's to one side and all my regular numbers to the other. So I'm going to move this y. So I'm going to subtract y to both sides. And then I'm going to, since I moved all of my letters that way, I need to move all my numbers this way. So I'm going to add 81 to both sides. And 2 minus 1 will give me y. And then 81 and 17 make 98. Right, and again, it's not degrees because you have to plug it in to find the degrees. So if I have 98, I have 98 plus 17 gives me 115. Then I'll have 98 times 2, which I do believe is 186. I might be wrong on that one. 196, sorry. Minus 81. Then we go back. Okay? Check them. That way you don't lose any points here. All right, last problem is application problem, probably the most useful piece of this little bit, especially if you build things. You'll use it constantly in carpentry, metal shop, those kinds of deals. It'll help you make something of a lot more structural integrity. Levi, I'm going to have you come sit next to me if we keep having the problems. You like that? Your group might. Okay, example 5, I'm just going to read it. The diagram shows part of a bridge where it contacts a vertical cliff. I don't know any cliffs that aren't vertical, but okay. So, that the bridge and the cliff are perpendicular, meaning they make a 90-degree angle. The angle between the surface of the road and the line extended from the bridge's support is 50 degrees. And it shows you that in the picture. It is important that the bridge's support be set at the correct angle to hold the weight of the bridge. What is the angle X that the support makes with the cliff? Okay. Oh, what the heck just happened? Sorry, I lost my page. Tell me what page number that's on. Thank you. Okay, I'm back. So the picture that they give you is extremely helpful. I'm going to show you how to redraw this picture so that you can get rid of all of the extra that's there, okay? So it has a top road, which was important because it referred to the top road when it dealt with this line. It said it made it a 50-degree angle, okay? And then it said that this vertical cliff, which is straight down, makes a 90 degrees, so it drew out that 90-degree angle. And then it asks you something about X, and it asks you something else about Y. Okay? Y is fairly obvious. What is the measure of angle Y? It's 50 degrees. How do I know that? Use the word. It's vertical angles. Thank you. So, Y is obviously 50 degrees because of vertical angles. Okay? Vertical angles. A word that we will use very frequently. Get used to it. Okay? If this is 50 and this is 90, how do I find X? I would set them equal to 180. So I would say, okay, 90 plus X plus Y equals 180. But I know what Y is now, right? So Y is 50. And then I start solving. I'd combine my two numbers into 140. And then I'd say X plus 140 equals 180. I'd subtract it from both sides and solve, right? So when I solve this, I get 40 degrees. To quickly check that, I just plug it back in and make sure it works. Any questions about it? Okay. That should be everything you need.